All right, so the next thing we're moving on to is summation results. Um, so these are the three results. You have result 1, result 2, and result 3. Result 1 says let C be a constant that the sum of C from R is equal to 1 to R is equal to N is equal to N multiplied by C. All right, so let me try and explain this. Whenever you, let us say, see something like this, let us say 5 is here, and this is from R is equal to 1 to, let us say, R is equal to 4. Notice that the general term, which is here, has no R in it. So what that means is that this series is not affected by the term number, which is R. So technically, what this is saying for you to do is that you're going to sum 5 4 times. So this actually means 5 plus 5 plus 5 plus 5. That's what it means. It's not affected by R. R does not change it in any way. So they're asking you to, it's typically you're being asked to sum 5 4 times. Now, the shortcut for adding 5 4 times is to simply multiply 5 by 4 or 4 by 5. That is what that is saying for result 1. Now, result 2 says let UR and VR be two sequences. So UR is a sequence that changes, that the terms in the sequence changes as the term number changes. In other words, term 1 is different from term 2, is different from term 3. As the term number changes, the term itself also changes. VR is also another sequence. And so in other words, you're summing two sequences in R. And what that is saying, what the result here is saying is that the sum, a series which is a sum of two individual sequence, is equal to the sum of the two sequences. In other words, you're separating the two sequences. And again, you will get a chance to see that in action. Result 3 is saying that if you have a sequence UR and it's being multiplied by a constant, that it is the same as saying the constant multiplied by the series itself. So here, the constant C is a part of the general term. And here, what you have is this entire series being multiplied by the constant. In other words, you sort of pull the constant out. All right, let's see some of this in action. So let's have a look at examples 13 and 15. Example 13 is asking you to find the sum of 5 from R is equal to 1 to R is equal to 20. Well, from this summation result, the one that says this, from R is equal to 1 to N of C being a constant, just a number, is equal to N times C. So the summation from R is equal to 1 to 20 of 5 is the same as saying 20 multiplied by 5, which is 100. Let's have a look at example 15. In example 15, we're asked to find the sum of R squared plus R. So in other words, that's two two sequences in R, from R is equal to 1 to R is equal to 20. Now, from summation results 2, I can separate this like this by saying that from R is equal to 1 to 20 of R squared plus R is the same as saying the sum from R is equal to 1 to 20 of R squared plus from R is equal to 1 to 20 of R. Now, of course, each of these have a formula. And so we can plug, well, let me just write the formula for the sake of sort of reminding persons. From R is equal to 1 to N of R is equal to N into N plus 1 all over 2. So what this is saying is that the sum of the first N counting numbers can be found using the formula. The sum of the first N counting numbers is equal to N multiplied by N plus 1 divided by 2. So N could be any counting number. It could be 5, it could, whatever. Now, the next one is this. From R is equal to 1 to N of R squared, which is the sum of the first, or the sum of the counting number squares up to N, or it's the sum of the squares of the first N counting numbers. And this is equal to N into N plus 1 multiplied by 2N plus 1 all over 6. Now, in the context now of our question, this is therefore equal to, from R is equal to 1 to 20 of R squared plus R. This is equal to, using the formula, I'm not going to have space to write it. Using the formula, this is equal to 20. So that's this formula here. 20 into 20 plus 1, 2 times 20 plus 1 all over 6. Plus, using now this formula, 20 multiplied by 20 plus 1 all over 2. So, of course, we can work this out using our calculators, which I don't have with me. So this is 20 times 21 times 41 over 6 plus, you could say 10 times 21, because 2 goes into 20 10 times. So using our calculator, this is 20 times 21 times 41 divided by 6. That works out to be 2,870 plus 210. And this is equal to 3,080. So the answer for example 15 is 3,080. All right, so example 14. The summation from R is equal to 1 to 100 of 8 is simply telling me to add the 8 100 times. And the shortcut for doing that is to simply multiply 100 by 8. So the answer here is 800. All right, using summation results, I think it's summation results number 3, which essentially says this, that from R is equal to 1, CUR to, let us say, the power n. This is equal to C from R is equal to 1 to n of UR. In other words, if we're multiplying it by a number, we can just simply pull the number out, add the terms in the sequence or in the series, sum the series, and then simply multiply by C. So that means from R is equal to 1 to 24 of 4R is the same as saying 4 from R is equal to 1 to 24 of R, and this would be equal to 4 multiplied by the sum of this series, which is what? 24 multiplied by 24 plus 1 all over 2. So this becomes 4 times 12, because 2 goes into 24 12 times 25. And this looks like 1,200.